the basic theories of relative velocity last week we discussed. But in this lesson, people, really we have some kinds of questions. First one, aeroplane questions. Second time, questions in the river. And third one, crossing the road. Fourth one, collision questions. Next one, fifth one, shortest path questions. And danger zone questions. And by combining two with triangles, solving questions. There are basically 7 types of questions. Okay. When you go through this past paper sums, you can see by all these kinds of types of methods, the questions available in past papers. So therefore, this is a little bit long lesson, right? Voice is not clear. What is the reason? Okay, people, then we'll write today the first type of question, a motion of an aeroplane. Motion of an aeroplane. Right. Motion of an aeroplane. Okay, people, now when we consider when an aeroplane moves, you know, aeroplane is I go like this. Like this. You know, the weight of this aeroplane is balanced by the upthrust by the air. You know that upthrust coming to this aeroplane according to the Bernoulli's principle you learned in physics. Okay, right. Sound is not clear. Everybody feel like that? Right, now, when this aeroplane flies in this way, people, its weight is balanced by upthrust coming to the aeroplane by the air. That occurs subject to the Bernoulli's principle you learned in physics. And people, the velocity required to move this aeroplane this direction is obtained or it is produced by the engine, right? By the engine in the aeroplane, and it exerts a particular force, that instance by smoke, right? Force is given to air, and as a result of that, air gives a force to the aeroplane this direction. Using that only, people, this required force to move the aeroplane rightward, it gets. So now, people, this way, by burning fuel in the engine, right, of an aeroplane, this way, a velocity can be created. This velocity, people, acts along the body of the aeroplane. What velocity? The velocity produced by the engine of the aeroplane by burning fuel. That velocity is always acting along the body of the aeroplane. Along the body of the aeroplane. Even this velocity, the engine of the aeroplane produces, is called as the velocity of the aeroplane relative to air. Relative to air. Remember that. Relative to air. Understand? Then, what is meant by the velocity of the aeroplane relative to air? That means, people, the velocity the engine of the aeroplane produces by burning fuel. By burning fuel. That's the velocity of the aeroplane relative to air. Nothing else. Remember this. Right. That velocity, people, always acting along the body of the aeroplane. Yeah. I'm going to take, people, that velocity as u. This velocity, u. What is this velocity? U. Velocity of the aeroplane relative to air. Right. Now, suppose this way. Now, suppose this way. While the aeroplane is moving, right, with this velocity u, right. Now, you know that aeroplane is really moving in the liquid, people. What is this liquid? This air, right? Liquid of air, right? Immersed in the liquid of air, the aeroplane now moving. So that means people really, if there is no air particle surrounding this aeroplane, you can very clearly understand people. This upthrust, which balances the weight of the aeroplane, not coming to this aeroplane, and therefore aeroplane can't fly like this. In order to get this way, the upthrust, definitely there should be air particles. That means definitely this aeroplane should move in a medium of air. You know, you have learned in physics the Bernoulli's principle. You know, this way the air particles are moving in two paths, right? Like this, when they move, there's a pressure difference, right? The upper pressure is people very low pressure, low side, right? People. There's a anyway pressure difference. You will in detail learn that in Bernoulli principle. So therefore, because of this pressure difference coming to the body of the aeroplane in the upward direction, a force is acting. Right? Yeah. By that, using that force only, the weight of the aeroplane is balanced. Right. Now suppose this way. Now the aeroplane immersed in this medium of air. Okay. Now this is the medium of air. Now suppose this air, this system of air particles begin to move. That is the one we identify as wind. These air particles begin to move. That means wind is blowing. These air particles begin to move. Then what happens, people? Once the air particles begin to move, really, if we say this, aeroplane is floating on air particles. Something like that really happening here. Once this whole medium of air begin to move, that means this is the one we identify as wind blows. When this wind blows, people, that velocity of the wind automatically comes toward this aeroplane. What reason? Reason is very simple, people. Now, when you sit in on a bus, people, suppose inside the bus you are now, once the bus moves, because between you and the bus there's a contact, the velocity of the bus you get automatically, right? And similarly, suppose a particular spring flowing, we put a piece of paper onto the surface of the water while it is flowing. Then what happens? The piece of paper moves with the water. Why? While it is in contact with the water surface, the velocity of the water surface, it gets automatically. Understand? Like that, here also, this aeroplane, people are immersed in the medium of air. Once this medium of air moves with particular velocity, since the aeroplane is floating on that, in contact with that, automatically that aeroplane gets the velocity of the wind. Now suppose a wind is blowing. For my convenience of explaining this, I am going to take a wind is blowing towards the board, Therefore, a wind will be moving this way towards the board, perpendicular to the board. Then, now the aeroplane was moving with velocity u. That velocity given to this aeroplane by its engine by burning fuel. That velocity acts along the body of the aeroplane. Now the aeroplane has that velocity. I am drawing another diagram like this. Like this. And now we said what, people, that wind blows towards the board, right? So then I am going to go that one like this. This is now 9, right? Now, people, what happens? Now the aeroplane will have two velocities. One is u, this way. Other velocities, people, towards the board, this way. Then finally the aeroplane will have two velocities, and then finally the aeroplane will be moving with the resultant velocity of these two velocities. Okay. The resultant velocity, people, will be acting. I'm going to do it like this now. these are the two velocities. V is what? Velocity of the wind. Then they are perpendicular to each other because we said that wind is blowing towards the board. Then there's a resultant velocity of this Q and V like this. Then finally, this resultant velocity people we can calculate. If we assume this V and U are two forces, how to calculate the resultant? Yeah, we start with square root from the same way. We can calculate the resultant velocity of these two velocities V and U, right? This way. Now, people, what happens is the aeroplane was moving this way, right, parallel to this board before blowing that wind. Soon after starting, the wind was okay. Right now, people. Right now, the aeroplane is now moving with the velocity this. This velocity is the resultant of this velocity and this velocity. That resultant velocity, people, we define as the velocity of the aeroplane relative to Earth. Then finally, the aeroplane is moving with this velocity to the direction of this velocity. So therefore, it was moving with velocity u this way, and the wind blows towards the board. Now the resultant velocity is acting in between these two like this. Then finally, the aeroplane is people, its body is pointing this way, and but while it is moving, it is really moving because of the velocity u that moves this direction. Because of the wind blows towards the wall, it is moving this way also. So therefore, it has the motion keeping the body like this people, that is moving really like this. Going forward, meantime, it is going towards the wall like this. Understand? Okay. So it is really moving, keeping the body of the aeroplane like this. It is moving really towards the board like this while it is moving forward. While it is moving forward, it is moving towards the board like this. Cannot. That is because of the resultant velocity of the aeroplane, right, acting this direction. Okay, this is really happens, people. So therefore, now suppose really the aeroplane need to move along the direction horizontal this way. It need to move. Now suppose this way wind is blowing towards the what people board. Then once it allow to move in the same way, really the aeroplane is moving forward. Meantime, it is little by little coming towards the wall while it is going forward like this. Then it can't go to its destination. Then the aeroplane should, of course, set its resultant velocity this to the direction it needs to move. Therefore, what does this pilot do, people? While it is body keeping like this, because of the wind blows, it moves towards the board. In order to go to its destination, that resultant velocity, right, should be in the direction parallel to board. Then what happens is the pilot what changes the direction of what its body like this. Understand? Then what happens? Now the velocity creating by its engine by burning fuel is acting along the body this way, right? And the wind velocity is still flowing towards the wall. Now people, the situation is like this. I can't draw in the 2D plane this way correctly. This is the direction the aeroplane need to move. Now its heading is people, the heading is its body is now pointing like this. Still the wind is blowing along this direction perpendicular to the board like this. Okay, now can you understand the situation? Right. The aeroplane need to move this direction. Now its heading body now change like this. Now the velocity of the aeroplane is along the body. Wind is blowing towards the wall. Then the resultant velocity will be people one occasion. The resultant velocity of these two set velocities will be acting along this direction. Then people aeroplane can go to its required destination, but while it is moving along that direction, remember its body is keeping like this and it is really moving like this. It's moving really like this. Understand? People, this motion we can very clearly identify, right? When you go to that airport and just before the aeroplane is landing, you can see, so you know, just before the aeroplane landing, people, that should really move a few circles, some occasions. A wind is blowing roughly, then you can see the body of the aeroplane is in a particular direction, but it is floating another direction because of this. You can very easily see. Now, usually we know people, when we consider vehicle, it is always moving parallel to its body, right? But not like that, people. The aeroplane, people, though its body is like this, when the wind is blowing, keeping the body like this, it is moving like this. That is because of, definitely, the aeroplane has to move with the air. But that situation not occurring for a bus. Why? People, the bus is always in contact with the ground. Ground is not moving as that air. Even though the air blows, people, the bus doesn't move. Why? Bus is in contact with the ground. Ground doesn't move, no. So therefore, the air, people, air, even though the air blows, that doesn't affect what velocity of the bus. Because bus is not in contact with the air particle, it is really in contact with the ground. In order to get such velocity, the ground should move. So that is why, people, that feeling we are not getting when you consider in our daily life. But people, you can very easily see this situation. Just before landing an aeroplane, you can see the aeroplane body is in a particular direction, but it is moving in another direction because of this situation. When the wind is not blowing there, people, definitely you can see to the same direction of the body, the aeroplane moves. So therefore, this part is very easy if you understand this situation here, right? What is the thing you have to understand here, people? First thing is velocity of the aeroplane relative to air. Velocity of the aeroplane relative to air means, people, remember the velocity, the engine of the aeroplane produces. That is called as the velocity of the aeroplane relative to air, nothing else, right? Okay, some occasions, some masters or somewhere you might hear, or some of your friends might say, when the relative means what, people? Relative to air means, people, what? Air is at rest, no? Air is at rest. When the air is at rest, the velocity of the aeroplane is the velocity of the aeroplane relative to air. That way you might hear. People, ignore everything. Ignore everything. Don't get such ideas. That idea is correct, people. But in different ways, sometimes you get wrong ideas once you remember that in that way. Reality is, people, this. What? The velocity. Whether the wind blows or not, people, that velocity produced by the engine of the aeroplane come into this aeroplane. That aeroplane, people, will be effectively coming to the aeroplane when there is no wind, and that velocity is always acting along the body. And even though there wind is blowing, people, still that velocity available for what? For the aeroplane along where? Along its body. In addition to that, velocity of the wind comes. Then finally, aeroplane will be moving, people, with the result velocity of that too. Understood? So therefore, the best way of identifying velocity of the aeroplane relative to air means, people, the velocity the engine of the aeroplane gives the aeroplane. That's the way. And once the velocity, once the wind is blowing, people, that velocity coming automatically to the aeroplane. Then aeroplane will have two velocities. One is the velocity along its body created by its engine. The other one is, people, the velocity of the wind. Then finally the aeroplane will be moving with the result velocity of that two velocities. That velocity only, people, we define as the velocity of the aeroplane relative to Earth. Finally, the aeroplane really moving along that direction of the result velocity of these two. That's all. Now, people, as I told you, now once this aeroplane is needs to move along a path parallel to this board, while moving like that, people, with the velocity u produced by its engine, suppose while moving like that, a particular wind is blowing towards the board. Then, if the direction of motion or the body doesn't change. The changing is body, people, the direction of pointing this body of the aeroplane, right? It is called as the heading direction. If this heading direction is not changed, then aeroplane is moving forward as well as towards what, then definitely the aeroplane can't reach to its proper destination. Then aeroplane should set its resultant velocity towards the destination. In order to get the resultant velocity, people, the body of the aeroplane should be changed like this. That is called as, people, heading. This is what really the pilots do. Understand? They have some equipments fixed in the aeroplane to measure the air velocity, its direction, and they get on the screen the destination they must move. Then people accordingly, until the result velocity coming along the destination line, they change the what? Body of the aeroplane. That is called as heading. Then people, the result velocity is now along the destination, and keeping the body like this, the aeroplane now moves like this. Understand? Okay, that's what really happens here. That thing only, people, you must understand. Okay, right. So then if you understand this part, people, all the questions under this you can very easily solve. Understood, right? Any question here, people? Yeah. Any question here? Right. Okay. Then people, shall we take down a brief note? Right. Okay. Write the heading as motion of an aeroplane. Write down like this. Write down the velocity. The velocity. The velocity produced by the engine of the aeroplane always acts along the body of the aeroplane along the body of the aeroplane along the body of the aeroplane and this velocity is called as and this velocity is called as the velocity of the aeroplane relative to air. It is sometimes known as the velocity of the aeroplane in still air. within bracket random O velocity of the aeroplane in calm weather. In calm weather. Right. Start from new line, people. Suppose a wind blows in a given direction. Then the aeroplane gets the aeroplane gets the aeroplane gets O acquired. The aeroplane gets O acquires the velocity of wind automatically. The velocity of wind automatically. The velocity of wind automatically. Now the aeroplane has two velocities. Then the aeroplane moves. Then the aeroplane moves then the aeroplane moves with the resultant velocity with the resultant velocity with the resultant velocity of these two velocities of these two velocities. This resultant velocity is called as this resultant velocity is called as velocity of the aeroplane relative to Earth. Velocity of the aeroplane relative to Earth. Right, we will draw this diagram. This velocity equal this resultant velocity. right now. Okay. Right, people, now we'll discuss more properties in this section, doing some questions rather than explaining. We'll discuss the question, then of course some more important points you can easily catch. Okay. And people, today I take my first question in the provided tutorial. Right. Last week, of course, one message was in the class, not last week, before last week. Without having the tutorial, we can't do the questions. People, then I supposed to post your tutorials again, right? Please, I'll put registration for the other class, tomorrow class. Today evening, I put that one. In that, I am going to include another question, your address. Okay. Don't send me the WhatsApp messages, people. My phone is full of messages. Then of course I can't clearly identify, right? So then I'll of course organize, in the sense I'm going to put the classes by registering you. Once I get the class, I include another question there, your address, your name, and clearly input your address there. From that, I'll take your address, and I supposed to post this tutorial within this week. Okay, we'll do tutorial. If there's no delay in post, people, you get the tutorial before the next class. I don't think that the postal department working properly. I don't know that, because not all the servants now working, right? So therefore there can be a delay. Anyway, people, keep this PDF. I'll post that tutorial during these 2-3 days. Okay, right. If there's occurring a delay in the post, people, then you won't get this tutorial before the next class. Then anyway, keep this PDF, right? Okay. Now can you take question number 20? Shall I read the question? Those who are unable to manage this question in the tutorial. Question number 20 in the provided tutorial. From a question, we'll discuss even more properties regarding this question. That is this lesson. Right. Take question number 20 in the tutorial. Question number 20. This says something like this. An airliner capable of flying with velocity v kilometers per hour on calm weather. That's how it says. An airliner capable of flying with velocity v kilometers per hour on calm weather. What is that, people? Velocity of the aeroplane relative to air. What is that? The velocity engine produces is v, right? Yeah, the velocity engine produces is v, kilometers per hour. Can fly non-stop a distance, capital R. Can fly non-stop a distance, capital R. What do you mean by that, people? Yeah. Now you know, people, in an aeroplane, the fuel storage is limit, people. Right? Then non-stop, it can move R kilometers mean what, people? The amount of fuel is sufficient to move, people, only for R kilometers. With what velocity? With the velocity v. Why, people? In order to create the velocity v, the engine must work at a particular rate. Once the engine works at that rate only, that velocity v comes to the aeroplane. Then the fuel burning, people, then the existing amount of fuel is sufficient, right, for a journey of what? R kilometers. Then people, you can very easily calculate the existing fuel, the time the existing fuel is sufficient. But people, how to calculate time? Maintaining the velocity v, the aeroplane can fly a distance r. Then apply F equals ut people. F is r, u is v, time is t. Then p equals r by v. Then people, when the engine works to create the velocity v, the available amount of fuel is sufficient only for the time given by r by v. I think you can very easily understand that. Okay, right. So now, what happens next? When there is a storm due north with velocity w, storm means what, people? Wind loss. Wind loss, right? So now, suppose this is our north. In this direction, the wind is blowing with velocity w, kilometers per hour. Right. The airliner, the airplane, travels non-stop from a city A to another city B, which is situated at an angle theta west from north. What is that, people? There is a city A here. There's a city A here. Okay. Then another city B, situated how? Which is situated at an angle theta west. An angle theta west from north. Therefore, people, facing to the direction of north, we have to turn towards what? Towards west. Towards west, no? By an angle theta. From north towards west by an angle theta. That means this. Here we have the city B. Okay. Right. Show that the distance traveled by the airliner in this journey is this. Right. Okay. People now, here we have to make another assumption. There you are given. There's a sentence like this. The airliner travels non-stop from a city A to another city B, which is situated angle theta west from north of A, and just comes back. What is meant by, people? Just come back. Once the aeroplane starts from here, going to this B and coming back to A. Just come back means, people, once the aeroplane lands again at A, it's all fuel completely finished. It's all fuel available, completely finished. That means, people, in order to finish all the fuel, we have calculated the total time the aeroplane must move is r by v. That means, people, for this particular journey, the aeroplane has taken this time for its outward and inward motion. From here to B and come back to A from B, the total time the aeroplane has taken is, people, this r by v. That idea we need to find. So then what is the question asking there? Show that the distance traveled by the airline. Distance means what? Yeah, if this distance from A to B is S or D, suppose, then distance means what? Outward motion D, inward motion D, D plus D is 2D. The total distance traveled by people 2D. Okay. That 2D only, people, we need to find. Is it clear? Yeah. All right. Now, people, you know Now, this is really happening in the horizontal plane. My body is vertical plane. But when you draw this diagram in your book, people, your book is horizontal one, the actual situation coming. Right? Now, I can't show this clearly in this case, people. Now, I try to show that one here. Now, the north direction is people this one. North direction is supposed towards, right? Towards this way, towards the board. Now, the aeroplane people must travel along a direction this, towards me. Wind is blowing this way. Aeroplane should travel toward me. Now, once the aeroplane is traveling towards me, now assume there is no wind. Right, now suppose towards me, the aeroplane must move. So therefore, its body should be pointed towards me, no? When there's no wind. Then without any trouble, the aeroplane now moves towards me with the velocity v created by its engine acting along its body. No issue. But people, while it is moving like this, when the wind is low, people, right? Then the aeroplane will have one velocity like this, that is that v and w here. Then the aeroplane will be moving this way. Then its destination is somewhere here. But because of the wind loss, the aeroplane will be moving along this path. It can't come to a destination. Then people, can you suggest me, in order to reach the destination, what should be the direction of the resultant velocity? This resultant velocity should be adjusted along this direction. In order to get the resultant velocity along this direction, people, this v must act this way. That means the body of the aeroplane should be turned this way. So that finally this v, now v is acting along this direction, finally this v and this w, they together should give the resultant velocity along this direction. Understood? In such a way that the aeroplane must turn its body. Then only that can go to the destination along this path. And for after going there, people, it should come back to this A again. Right? So once the aeroplane turn its body along this direction from this B to A, because of this W, people, it will get this one. Then the result will be along this direction. Then it can't come towards A. Then in the backward motion, the aeroplane must turn its body in a direction like this. Then this W and this V finally will give a result like this, and it can come to A. Here you can very clearly understand. There are two resultant velocities we need to find for two journeys. One from A to B, the other one from B to A. People finding resultant velocity means what? By applying principle of relative velocity, we find that velocity. So therefore, in this case, we have to draw two velocity triangles to find those two resultant velocities this aeroplane has. One is for the journey from A to B, other one is from B to A. Understood? So therefore, two velocity triangles we have to draw. That both triangles, people, we are going to draw in the same diagram now. Understood? So then, people, we need to find what velocity? The resultant velocity. What is the resultant velocity? Velocity of the aeroplane relative to Earth. Then what we do is this. First of all, when you are given a question like this, people, the given data we mark. What is this V? Velocity of the aeroplane relative to air. What is this W? Velocity of air relative to Earth. Then what velocity we need to find? Velocity of the aeroplane relative to Earth. That one only we need to find. Velocity of aeroplane relative to Earth. By that velocity only, people, actually the aeroplane moves. Once an observer on the Earth observes the motion of this aeroplane, people, definitely that aeroplane is moving to the direction of the resulting velocity. That is the reason why we call that velocity as the velocity of the aeroplane relative to Earth. So therefore, we write the principle of relative velocity subjecting the velocity of the aeroplane relative to Earth. Understood. This is what we must do. Okay. Right. So then we will start the discussion like that. Right. Okay. So then this is the diagram. This is north direction, people. This is the city A. This is B. This is C. Right. This distance I will take as B. Then what are the non-velocities? I am going to take A as, yeah, no. Aeroplane also we take, no? Yeah. We take people W in A aeroplane, the Earth. Okay. What are the velocities we have, people? Velocity of wind related to Earth, u naught with W. Right? No? W. Velocity of aeroplane related to wind, given as people, we know in the question. V. Right. Its direction not definite, people. Direction of the velocity of the aeroplane related to air, it is along the body. What is the direction of the body of the aeroplane? To that direction only that velocity we act. Right? We don't know what is that direction, the body of the aeroplane now, what? Direction. So therefore, we don't know the direction of that V2 mark there. Understood? Okay? Right. Now we know, people, we have the subject, what velocity we need to find now? The velocity of the aeroplane relative to Earth. Now subject in that, people will write the principle of relative velocity. Okay? Write down. By the principle of relative velocity, now you can write velocity of the aeroplane relative to Earth. Velocity of the aeroplane relative to Earth. B, E, comma, W plus B, W, comma, E. People can remember, soon after writing principle of relative velocity, I told you something to do. What is that, people? For every velocity, you have to write what? Vector. Okay? Right. So then I'm going to take this as PQ. This one as QR, people. Therefore, their sum is given by what? PR, like this. Sum is given by PR, like this. Understood? Now we have to what? Mark this. PQ, velocity of the aeroplane relative to V. It is V, but direction is unknown. Then what we do? We write V, and given by the vector PQ, we mark like this by writing the corresponding vector within bracket like this. People QR, velocity of wind relative to Earth, that is point in due north. So this is W naught. QR. Right. Okay, people. Right. Even now, can remember, in this case, we can draw the both triangles, vertical triangles. There are two vertical triangles. One is from A to B journey, other one is from B to A journey. That is why we say, since there are two journeys, there are two vertical triangles. That both vertical triangles, people, we are going to draw in one diagram. There we use that circle method. People can remember the circle method. Under the circle method, I said you. Huh? How to draw that circle? Yeah, the fixed one in magnitude and direction we know, right? The common point we take as the center of the circle. And the fixed velocity, which is known in both magnitude and direction, that is taken as what the radius, and we draw the circle. Understand? Draw the circle now with the center Q and radius B. Okay, right now. Count that, people. Count that. Okay, now we draw a circle with center Q and radius B. Right, this way. Here, Q and R. Right, people? This is R. This is PR. Okay, PR way. Right, because remember always, by this PR vector, we get what? Velocity of the aeroplane related to Earth. Okay, up to I think you can clearly understand. This looks like a circle. No, we have to assume this as a circle, right? This is a circle, right? Right. Okay. Okay. Anyway, I think that is right. Okay. Right. Now, what we need to do is this. Right. Now, first I'm going to consider first one. Journey from A to B. Journey from A to B. Even when the aeroplane moves from A to B, it needs to move with speed, no? Then that resulting velocity should be pointing along AB, no? Resultant velocity means what? Velocity of aeroplane to Earth. Velocity of aeroplane related to Earth should be pointed this way. P and here R. Then only it can move toward its destination B. But you know, people, that is given by PR. Then this time I'm going to say this as PR1. PR1. That takes I denote by PR1. People, where does this P lie? We drew this circle so that its radius is V. Its radius is V. Right? This V is denoted by PQ. Q is here. Then definitely, since the radius of the circle is V, definitely the point P should be where on the circle somewhere. Right. Now, when the aeroplane moves from A to B, people, that P should be how, people? I take it as P1, people, not R is a common P1 R. Point P only changes for both what? Journey. P1 R. I am going to take not PR1, P1 R. Then can you tell me where should be the point P1 to get this P1R vector in the direction A to B? People, I am going to draw from this point R a line parallel to this AB, this way. Okay, this line I drew is parallel to what? This AB. Then that line, people, cut this circle somewhere. That point of intersection is P1. Then, people, the first triangle for the motion of the aeroplane from A to B, now we can prepare how it is P1QR like this. What is this P1QR triangle? Is the velocity triangle for the motion of the aeroplane when it moves from A to B. Then, people, by this P1R, by this P1R length, what do you get? By the P1R length, you get people the size of the velocity. What is that? The resultant velocity. In other words, the velocity of the aeroplane relative to Earth. Understand? Right. P1R gives the velocity of aeroplane relative to Earth when it moves from A to B. In a vector, you know, vector is denoted by the line segment along with arrow or people. Then by the length of line segment, what do you get? Its size, magnitude. So therefore, by using our trigonometric knowledge, using sine rule, cosine rule, and all people, now we should be able to find out this P1R. What is that? It is the size of the velocity of the aeroplane relative to Earth when it moves from A to B. The first triangle is okay. Secondly, people, I consider second journey from B to A. After reaching to the city B, people, that should move again toward A. Then in backward motion, in order to come to the city A, definitely the velocity of the aeroplane relative to Earth should be pointing along BA line. In other words, that resultant velocity of wind and the velocity of the aeroplane should be pointing along BA line. Then only the aeroplane can come to city A from B. For that one, people, I am going to assume velocity of the aeroplane relative to Earth should be now pointed this way, no? This line is parallel to this BA. Then I am going to take that as P2R. This angle is theta. Okay. Now, can somebody tell me where should be the point P2? Where should be the point P2? P2 should be there. Here, P. This is R. Okay. Then what is the velocity triangle for that? It is this. P2QR. This is. Then first triangle, P1R is this, W is this, P2R is this. Right. People, what is this angle theta? How do you mark this angle theta? Angle theta, people, when you draw this way a line, this way a line, right? This is the angle theta. This line means, people, that AB line is parallel toward this P2R and this P1R. Then can you mark theta in this velocity triangle? It is this, people, no? This W line is this north line. This line is parallel to, we said, AB. So therefore, the angle between north and this is theta. Therefore, this angle is theta. This length from here to here is W. Now our purpose is what, people? To find this P1R length and P2R length. Understand? Then this velocity, the radius of the circle, people, we know V. So then by the PQ line, we get V. This is V and this also. Then see here, we drew the both velocity triangles for the motions of the aeroplane from A to B and B to A in the same direction. Can you understand up to here? Yeah. Because now here, without saying something, I drew this one. What is that? People, I have taken this W to be smaller than this V. The reason we can very clearly understand. If we consider the other way around, that means W is greater than V. That occasion, people, sometimes we can't find what? Sometimes only, sometimes we can't find a point P1 parallel to this AB and point P2 parallel to this BA. Okay. Sometimes here it is possible to find this P1, but other directions we can't find a point P2 on the circle. That location, in the backward direction, once the aeroplane begins to move, people, it can't move from B to A direction. The reason is no point on the circle for P2, so that P2 and this R to point in the direction B to A. Okay, right. That is not given in this question, but practically once you do the questions, you have to understand if this what motions are possible, then the velocity available relative to Earth, for the velocity to be able to find, the W should be less than V. Accordingly, you have to think and determine this circle should have greater radius than W. But in the examination, usually we are given the relative sizes of the velocities. Okay, if you are not given like that, people, no need to worry. By once you start to do the question, if you can't do the required velocity, if you can't find the velocities in the required directions, thereby you have to understand, then if the finally, if the motions are possible, then Wilson triangle should be possible. Then according to that, you have to adjust to a radius and other things. Okay, if you're not given the relative sizes of the velocities in the question, right? Okay, people, now our purpose is to find people this P1R and P2R velocities. Understood? Okay, P1R length and P2R length. Now you have to use your trigonometry knowledge. By using the trigonometry knowledge, we can do this, right? People, now this is how we do. You can very clearly understand that this length and this length being equal, the same radii of the circle. So therefore, when I consider this triangle P1, Q, P2, P1, Q, P2, this whole triangle, when I consider, people, that triangle is an isosceles triangle. Okay, then the angles which are opposite to equal sides should be equal. So therefore, this triangle and this angle should be equal. I'm going to take that angle as alpha. Understood? Now you can find, people, this alpha. How to find this alpha? Alpha can be found, people, by using sine rule to the triangle P1QR. To the triangle P1QR, we apply sine rule. What is sine rule? V divided by sine theta is equal to W divided by sine alpha. By that way, you can very clearly find what the alpha, right? To start, people, this way, apply sine rule and take this alpha. And now write by sine rule to the triangle P1QR. What do you get? Q of sine theta equals what, people? W of sine alpha. Subject sine alpha by using cross multiplication. Sine alpha equals W sine theta divided by V. Right. Okay. Now, people, how to find this P1R? That can easily be found like this. I drop a perpendicular from this Q on this P1R like this. I drop a perpendicular like this. This way I draw a perpendicular. Right? This is W. This velocity is W, right? People, now, can you tell me what is this velocity? This is W, this is theta, here 90, therefore this length is W cos theta. What is this velocity? This is V cos alpha. Okay. Then what is P1R? P1R going to be, people, what? This V cos alpha plus W cos theta. V cos alpha plus W cos theta. Okay, right. We are not going to find this cos alpha right now. Okay, we'll do that later. We'll keep this cos alpha in this case, right? Now, people, can you tell me how to write this P2R? P2R. This whole thing is what, people? From here to here. This is V, this is alpha. Therefore, this is V cos alpha. From here to here, it's V cos alpha. This is W cos theta. Then what is this? This part is, people, V cos alpha minus W cos theta. V cos alpha minus W cos theta. P2R. V cos alpha minus W cos theta. Okay, those we obtained by the velocity triangles. Right. Right. Now, we have tried. Next one, what? Now, we are given at the very beginning of the question like this. The aeroplane can move non-stop r kilometers. What do you mean by that? When there is no wind, if only the velocity produced by the engine of the aeroplane acts on the aeroplane, with that velocity, aeroplane can move r kilometers. For that journey only, the fuel available is sufficient. By that, people, we can calculate the time for which the available fuel sufficient. Understand? Right. Okay, you can write like this. You can write like this. Shall we, people, first write this way? The time for the 8V journey and VA journey, we'll do. Write down like this. Thereafter will come that. Right. Write down like this. We assume this way. The distance AB as D. Okay. Write down like this. Let AB distance BD. Now write down the time taken by the aeroplane, for the journey from A to B. For the journey from A to B. People, I'm going to take that time as TAB. I denote that by TAB. People, how to find the time? Time means the distance divided by the velocity. What is distance from A to B? It's D. This distance, now the aeroplane moves with what velocity? P1R. Why? P1R is the velocity of the aeroplane cradle to earth when it moves from A to B. Understand? P1R. Secondly, the time taken by the aeroplane to move from B to A. Right down. Second one. The time taken by the aeroplane to move from B to A. B to A. TBA. Again, what distance when it moves from B to A? D. What is the velocity with which the aeroplane moves from B to A, people, relative to Earth, given by this P2R. This P2R, this point P2 we named by ourselves, right? Yeah, P2R. D divided by P2R. Okay. Then people, can you tell me the total time taken from A to B journey and B to A journey? This sum, no? Sum of these two, right? Now you can write the total time. Now you can write the total time taken by the aeroplane to come back to the city A. Total time taken by the aeroplane equals TAB plus TBE. TAB plus TBA. Right? Then we can write that one as how, people? TAB means D upon P1 plus D upon P2. We can take this D out, people. What is that? 1 upon P1 plus 1 upon P2. This we can write. So this is equal to D times. People take here the common denominator as the product of this and this. P1R into P2R. Then this P2R comes here, P1R comes here, no? Right. This now P2R plus P1R. Right. Now people substitute for this P1R and P2R. What is P1R? This P2R is this. P1R is, people, fill this V cos alpha plus W cos theta. P2R is this, people, V cos alpha minus W cos theta. And the product P1R, P2R product at the denominator. V cos alpha plus W cos theta times V cos alpha minus W cos theta. You see, VJ. People, this W cos theta, you can cancel on with this W cos theta. Okay. So what do you get here? V cos alpha and V cos alpha is equal to V cos alpha. Here what do you have? This bracket is like A plus B into this bracket is like A minus B. People, what is A plus B into A minus B? It is A squared minus B squared. Then square of this minus square of this is the corresponding difference of two squares we get by this product. Okay, right? We'll mark that. Here we get the total time mass, people. D times 2V cos alpha. It is V squared cos squared alpha minus W squared. Now substitute, people, for cos alpha, right? Yeah, here we can write 2dV cos alpha. People, how to write cos alpha? It is the square root of 1 minus sine squared alpha, no? Square root of 1 minus sine squared alpha is the cos alpha. Denominator we have cos squared alpha. B squared times cos squared alpha means what? People 1 minus sine squared alpha minus w squared cos squared theta. Now substitute for sine alpha. What is sine alpha here? This w sine theta by v, right? 2 dv 1 minus sine alpha w sine theta upon v, no? Square that one. W squared sine squared theta divided by v squared. And here also, the denominator, this sine squared alpha is now w squared sine squared theta divided by v squared minus w squared cos squared theta. W squared cos squared theta. Right. Okay, people, now we can take here. Take this v squared as common denominator. Once you take that as common denominator, this 1 will be v squared. V squared minus w squared sine squared theta divided by v squared, but that v squared is inside the root sign. Take that out. That will be v, but that is coming under this v. That 2v figures get cancelled and giving 2d here. Square root within the root sign. This is now v squared minus w squared sine squared theta. Right. 2dv. Right. This way we take the common limit as v squared here. That v squared comes before here, people, like this. Minus w squared sine squared theta divided by, because here remove the bracket by multiplying this v squared, this 1 and this. What happens? V squared into 1 is v squared. Okay. Once you multiply by this v squared, that comes here, that v squared, then this v squared, we can cancel down. Then we get w squared sine squared theta, right? Another w squared cos squared theta, people, we have another w squared cos squared theta we have. Okay. That is. By this term and this term, you can take this minus w squared out. And this v squared you can take out. That v squared, then this we can cancel down. Once you take that v squared out from the root sign, people, that will be v. That v and this v we can cancel down. Then we get 2d times v squared minus w squared sine squared theta. Take this w squared out. Then once you take w squared out, people, here this is now sine squared theta plus this is now cos squared theta. People, you know sine squared theta plus cos squared theta is 1. This is 1, right? Then we get 2d times root v squared minus w squared sine squared theta divided by v squared minus w squared. What is this, people? This is the total time taken by the aeroplane to move from A to B and back to A. Right. Now, people, what is the story? Story says once the aeroplane comes back to the city A, We are given it can just come to the city A. What do you mean by that? Once it lands city A, people, the whole fuel will be over now. That means we know the available fuel becomes zero after what time? R by V. No? We'll calculate that one. Therefore, that time it should be equal to what? This time. Understood? Why? The total amount of fuel available at the moment will finish, people, after the time R upon V. Here also we are given once the aeroplane comes to the city A, the fuel what finishes. That is what the meaning just come. Okay. Write down now like this. Write like this. We are given that aeroplane can fly non-stop a distance r kilometers while its engine works to give the velocity v to the aeroplane. Therefore, the time the available amount of fuel sufficient for the time available amount of fuel sufficient. What people? By S equals ut. S is R, U is V times T equals R upon V. Is by down R upon V. Right. People, this is the time during which we can fly non-stop with the all fuel available in the aeroplane stop. But in this case, we are given after this time, the aeroplane came to the city A. By that occasion, the all fuel finishes. So then this time and this time should be equal. Understand? Okay. People, now the aeroplane may be moving any path. The path changes because of the wind loss. Every instant, the engine of the aeroplane works at a rate so as to give the velocity v. Therefore, at the constant rate, the engine works. So therefore, in 1 second, the amount of fuel burns, people, equal throughout the journey, throughout the engine works at that rate. Okay, so therefore, we don't think the distance that has moved, the direction that has moved, whichever the distance and direction, people, the engine works at the constant rate so as to burn the same amount of fuel in each second. Once it works the engine like that, people, it takes time R upon V to finish what all the fuel. The same thing happened here, people. Once the fuel finishes, when it comes back to the city A, the time here, this we calculated, should be equal to this time. Therefore, you can write, therefore, people, therefore, this equals R upon V. This one you can write equal to R upon V. Is equal to R upon V. Now people take the answer. I think you can take the answer. People in the question asking the total distance traveled by the aeroplane. What the total distance traveled by the aeroplane? From A to B, D, from B to A, D. 2D. Then we have to find 2D, not D, 2D. Right. Then subject 2D by this. Take this here. This is equal to R times, right? B squared minus W squared. Right. Is this not distance travel? Right now, people. Everyone now take the question number 21 as next. Number 21. Now this time the aeroplane is moving along the triangle. Okay, right. Take 21. These people, this lesson is very easy lesson. Every lesson, of course, when I teach, I say easy, but you find some difficulties. No, people, really they are very easy. Only thing is, at the very beginning, you have to understand. Don't actually confine only on getting the answer. Once you always focus to get the answer, people, then only most of the occasions you find some difficulties once you get a particular different question. So what try to understand always the thing really happens there. Then people it is very interested. Okay. Otherwise, when you focus to get the answer, people, whatever the method, never mind, you need the answer. People don't study like that. Right? So then you should get a solid knowledge. Once you get solid knowledge, people, this you have to analyze and learn. Solid means what, people? One by one, with your present knowledge, you should be able to solve anything. For this people, for this property, you should have a good understanding. Having a good understanding, people, when you do whatever the question, little by little, you can solve the question. Finally, you can go to answer. So that is the meaning of solid knowledge. Okay, right. So then read the question number, people, 21. Read question number 21 in tutorial. And try to start to this question, people. Okay, you are given number 21 like this. 3 airports A, B, C are situated at the vertices of an equilateral triangle of side A. Right, this way, right? Equilateral triangle. A, B, the side is simple A. Side of plane, simple A. Right. On a calm day, people, what is meant by calm day? Calm day means what, people? No wind blowing. On a calm day, when there is no wind, an aeroplane travel with maximum speed V. What is this velocity, people? When there is no wind, if the aeroplane moves, people, what is the supportive velocity to move this aeroplane? Only the velocity created or produced by the engine, no? So what is that velocity? Velocity of the aeroplane relative to air. Understand? Right. Then I take W as the wind or W as the air. Right? For the wind. And people A as the aeroplane. And people E as the earth. According to this given thing, people, velocity of the aeroplane relative to the wind. is given as people maximum speed v means that v. When the wind blows in direction AB with velocity u, in the direction AB, this direction wind is blowing with velocity u. Velocity of wind related to Earth. Given that v greater than this is an equator triangle, people. Therefore, interior angle is 60. Then one's asking, yeah, show that the minimum time taken by the aeroplane to travel non-stop the course A, B, C, A. Aeroplane start from A, come to B, and B to C, and C to A. There are people 3 journeys. First one is from A to B, then B to C, then C to A. People, how many velocities relative to Earth this aeroplane will get? Since there are 3 motions, people. What are the motions? From A to B, 1 motion. From B to C, another motion. From C to A, another motion. There are 3 motions. There will be 3 different velocities for the aeroplane relative to Earth. To find each velocity, people, we have to draw a triangle. Then 3 triangles this time we expect. How to draw the triangles in the same diagram? People use a circle method. What is the circle method? Subject the velocity of the aeroplane relative to Earth and write commonly only one time what? The principle of relative velocity. Then usually according to our notation of the vectors, the velocity of the aeroplane relative to Earth as before, people, given by PR. That point P should lie on the circle. Since there are 3 cases, there are 3 answers for PR. Then we'll take, people, that velocities as P1R, P2R, and P3R, and calculate that 3 velocities, right? Yeah, asking another question like this. So is there are other methods. Other method is, people, drawing the triangle separately. Don't familiar to draw the triangle separately, because most of the time at the examination asking draw all the triangles in one diagram. People, if we are okay to draw the all triangles in one diagram, if you need to draw separately, then take each diagram out. That is easy. But people, most of the time, same diagram, draw velocity triangles and find this answer. That is how you are given in the question. So therefore, familiar to draw all the triangles in one diagram. Understand? Other method is drawing single diagram for the single motion, and 3 velocity triangles for the 3 journeys separately. That is nothing, right? So then I give you 5 minutes. Draw the triangles by subjecting velocity of the aeroplane to Earth by using the principle of relative velocity. Draw a circle, draw a circle, and take the 3 triangles. Okay, and we'll find that 3 velocities P1R, P2R, and P3R. Okay, we'll find the time there. Okay, I'll give 5 minutes, people. Take. Right. Now we write by the principle of relative velocity. Get of plane okay. Velocity of aeroplane relative to the wind. Velocity of aeroplane relative to the wind is v. V. W E. It's v. Now there draw a circle. The same side is vector PR. Common point is Q people. We are given U smaller than V, V greater than V. Right? Do a circle with radius P. No? You know the center is taken how people the common point to the right hand side. It is Q, center is Q. For radius, this one. Okay. Now this is the center is Q. Now people, one by one will come to the journeys, right? Our first one is AB journey. AB journey. Right. AB journey. People, once the aeroplane moving from A to B, its velocity of the aeroplane to Earth. To Earth. Now, when the aeroplane people move from A to B, its direction is A to B. The velocity of the aeroplane relative to Earth should be along A to B and this direction. Right? That vector I am going to divide by commonly it is PR. But since here in the same diagram we have three velocities to find, I take that point P1, right? P1. Now, people, the point P1 should be on the circle. Somewhere on the circle, definitely. Every point P1, P2, PR, every point should lie on the circle. Why? Here, PQ vector is of size V. What is this V? Radius of the circle. Then the distance from any point on the circle to the point Q is V. That is why we say any point P should lie on the circle. Now this time what point we need as our P1 people? We have to select the point on the circle as our P1 so that P1 and R when we join that should be pointed rightward. Since here we have R people, point P1 should be like this. No? Point P1 should be here. Then only people this P1R will be pointing rightward because of A to B direction we get by that. Understand? Then point P1 is here. When we produce this line that cuts this circle somewhere, that point only people P1. Okay. P1. Then this is UV, no people. Then what is the velocity relative to Earth of the aeroplane when it moves from A to B? People, for the AB journey, velocity of aeroplane to Earth is given by P1R. What is now this P1R? The distance from P1 to R. V, U, this is V, no? This is V plus U. V plus U. Understand? Right? Can't it cut the other end? Other end of the circle when I can't like these people, this is our P1, then P1R, pointing leftward. Does the aeroplane going from B to A? No, A to B, right? Here, velocity of the aeroplane is given by P1R. Here, PR vector always representing what? Velocity of the aeroplane relative to Earth. When it moves from A to B, it should move according to our notation of the triangle. AB is pointing rightward, no people. Then the P1R vector should be pointing rightward. When you select the P1 here, P1R pointed leftward, then it is coming from B to A. No, A to B means P1R, P1 should be on the left hand side. Huh? Like this. Then P1R is what, people? P1R vector, very easily we can write it's B plus V. Then the velocity when the aeroplane moving from A to B is people V plus U. V plus U. Understood? That's true, no people, right? When we move, when we run to the right, wind blows to the same direction and it pushes us to the same direction and increasing the velocity. That is how here G plus U the throttle comes. Now, second motion, people. Second motion, I am going to consider number 2. It's BC journey. Velocity of the aeroplane to Earth should be pointed like this, huh? Because BC no, BC no. I am going to take that as T2 R. This angle is 60. P2R. P2R. Can somebody tell me how to find point P2? People. Through the point R, draw a line parallel to this BC. And not only that, starting from P2, when we go to R, that direction of motion should be from B to C. Therefore, definitely not by producing this line to this end, the point of intersection for P2, it is this. Point P2 is this. Right? That is the point. This is U. Then our triangle is not people. Our triangle is PQR. No. Then this time, since that point P is P2, now the triangle is P2QR. So therefore, the triangle is this. I take the point R here. Right. That's also okay. P2R now, directly we can't calculate as we did here. We have to separately calculate that by using the diagram, right? Yeah. Now, people, the next one is the journey, CA journey, number 3. CA journey. Velocity of aeroplane relative to Earth. People should be this way, no? I take a 10 P3R. This is 60. Then what we do, people? We draw through the point R a line parallel to this AC. Yeah, like this. Once you draw it like this, the line can be produced like this. Then there are 2 locations for the point P2. But finally, when we move from P2 to R, that direction should be from C to A. So therefore, definitely point P2 should be here. Then only we move from P2 to R, we get the direction from C to A like this. Right. P2 R. Then what's the triangle? P2 QR, no, this is U, right? This is the triangle. Good triangle, right? So this is Q. These are the 2 triangles people now. Only 2 triangles we get in this case. Then we have to find what people? This here, not P2, P3R. 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 This point is P3, not P2. P2 is the early one, P3R. Right, people, now what's the angle? This angle is what, people? That angle means this P2R is parallel to this one. This is P2R. Okay. Then when it comes to this way, people, this is the horizontal line. This angle only here we have. This angle is the one here we have. This is 120. Therefore, this is 120. Okay. This is 120. Right. And what is this angle? This line is this. This P3R is this. Then this angle only people here we have. Therefore, this angle and this angle is 120. Right? 120. Right? This is 120. And this also 120. And this P2Q. This is B. Okay, no? Right. Now, people, we have to find out this P3R and P2R. By using your knowledge of what? Sine rule, cosine rule, people try to find this P2R and P3R. This is 120, right? Okay. Try to get that. Right. So we have 2 seconds, people try to get that. Yeah, let's see how to calculate this P2R and P3R. Yeah. Right. Okay. P2R, when I calculate people, I do a construction like this. This is 120, no? If I make that construction in this diagram, you can't see a clear diagram here. Right? What I do is this triangle I take out this way. Q R P2. This is 1. This is people B. Since here we have 120, once we produce this way the P2R line, people, I can prepare this way a right angle triangle. This is U. This is a right angle triangle we can prepare. If I take this angle as alpha, people, this line, this length you can write as V times, since here 90, V times sine alpha. The same length you can write, people, by using this U. When this angle is 120, this is 60, no? Right? This is 60. Then the same length I can write as U sine 60. Understood? U sine 60. Right? Then you can subject sine alpha, the angle is. Therefore, you can write V sine alpha equals U sine 60. B sine alpha here, people. We can divide by V. Sine 60 is root 3 by 2, no? Root 3 by 2. This is U. This V comes here. This way. Then you can write P2R. What is this P2R? Yeah. What is whole length? B Whole length means from here to here, right? V cos alpha. The whole length from here to here. From that, we'll subtract people this length. U cos 60. That's right. Then we can write P2R is equal to the whole length, this V cos alpha. From that, subtract people this U cos 60. P2R. Okay. Right. Similarly, we can write P3R people. Similar construction we can go there. Yeah. If I take that triangle out this way, P3, this way I produce this P3R. We draw a perpendicular like this. This is U. This is equal 60. Right? This is V. So I take this angle as beta. You can write beta. V sin beta, this thing is equal to U sin 60. U sin 60. Right? So then what we get? Sin beta can be subjected. U sin 60 means people sin 60 root 3 by 2, no? Root 3 U by 2, and this becomes, you can very clearly understand alpha and beta are equal now, right? Okay, now people, we can write this P3R. Therefore, P3R is what people? Explain. Once from this whole length, what is that? V cos beta. Right? Whole length means this, no? V cos beta. From this V cos beta, we subtract U cos 60. Then you can very clearly understand P3R will be equal to what this P2R, right? V cos beta minus U cos beta. Beta, since beta equals alpha, you can see here sin alpha, this sin beta also the same, then alpha and beta being equal, beta equals alpha, you can write this beta as alpha. V cos alpha minus U cos 60. Given that, this implies P2R and P3 are being equal. P2R and P3 are being equal. Understood, right? Right. People must very carefully hear to the this one. Maybe sleeping some of the students asking this, how can this be 120? This line is this, right? This line is this, right? This is 60 because equal to triangle. This is 120. That 120 here we have. Now understood, right? Okay, similar to the other one, now that P3R makes 120 with 2R. Yeah. Now we know the time. Total time taken. The time from AB. What is the AB length? Simple A. What is the velocity when the aeroplane moves from A to B? We found U plus V. Then what is the time TAB? Simple A divided by velocity. No, time is what? displacement divided by velocity. No, right. Now we'll calculate one by one the velocity. Sorry, time. Right. Okay. Now we can write PAB. PAB. We can write now. A divided by Q plus C. BC. A divided by what is the velocity people from B to C? P to R. PCA. A divided by P3R. But P2R and P3R being equal, then I can put for this P3R again P2R. P divided by P2R. Right? Then total time, the sum of this. Total time. PAB plus PBC plus PBC upon U plus V, PBC A upon P2R, PCA A upon P2R. A upon U plus V. This plus this means people 2A upon P2R. Right. Substitute for this P2R. You can take this. Right. P2R. V cos alpha minus V cos 6. For cos alpha, you can write as how 1 minus and square alpha root cos alpha, right? You cos 6 to people. 6 is half. Sin alpha is this answer. Put that here. Sin square alpha 3u squared divided by small b squared minus right. Now people here take this 4b squared as common denominator. Then this will be 4b squared, right? Minus 3u squared, right? Therefore, b plus four b squared minus 3u squared divided by 4b squared. Because this v squared we can take out, that will be v, that v and this we can cancel out. Root of 4 is 2. That 2 and this 2 common, no? Also divided by 2. This 2 comes to numerator. Yes. But this is not the answer asking people. This is not the answer asking. Right? Answer is this will be different from this. And then what I do is this. I'm going to multiply this numerator and denominator by the conjugate of this denominator. What is the conjugate of this denominator? They give sign to plus. By that, multiply numerator and denominator both. C upon u plus v for a times the conjugate going to be this. This is conjugate what is divided by plus v for a root 4b squared minus 3b squared plus u. Now, people, what do you have here? A minus b into a plus b. What is that? A squared minus b squared. No. Then square of this root means the root will eliminate. 4b squared minus 3b minus b. This is what we get. No. Make a lamaya patla pin. More 11 here for u plus v for a times square root of 4b squared minus 3u squared plus u divided by here 3u squared minus u squared is 4u squared, take 4 out, b squared minus u squared. Okay. Now this 4 and this 4 you can cancel. Now take people this common denominator as b squared minus u squared. Take the common denominator as b squared minus u squared. Then this v squared minus u squared means people v minus u into v plus u. We can factorize this into 2 factors v minus u into v plus u. Here now we have v minus u into v plus u. But here we have v plus u. Now v minus u factor by the v minus u factor we have multiplied this. A times v minus u. And a times this. People here a times u minus a u, you can cancel down with this a times u this. Then what do you have? You can take this a out from the numerator, then here we get v plus this divided by this as the last answer. That is the asking answer, people know. It is now take that a out. V plus this, no? Right. V squared minus V squared divided by V squared minus V squared. This is how we take it out. Right. Even another part is there. What the next part? On a calm day, if it requires capital in liters of fuel to travel along ABCA with velocity V. On a calm day means what, people? No weather, no wind. That occasion, right? The aeroplane is moving with what velocity? With the velocity its engine produces. What is that? V. That velocity we define as velocity of the aeroplane relative to wind. No. With that velocity only now aeroplane moves. Okay. Then what the time it takes from A to B? Time. What is people? What is time? Displacement A. What velocity? V. A by V. From here to here also velocity V. No. Time is what? A by V. From here to here. Right now. We are given right now. Write down like this. On a calm day, the airplane moves along the sides of the triangle with velocity V. With velocity V. Therefore, the time the aeroplane takes to complete the arc ABCA is, what is total distance? A plus A, 3A. With what velocity that moves? V is the time. Right? V by V is the time. Right. Now people, we are given on a calm day, once this aeroplane completes this ABCA path, the aeroplane takes capital N number of liters. Capital N number of liters. Then people, can you calculate the number of liters required per hour? Per hour. People, suppose this is like 10 hours. For 10 hours, N liters required. For then 1 hour, number of liters required can be calculated, people. N divided by this time, no? Okay, I like that. number of liters per hour can be calculated n divided by this. Understand? Okay, write down online. Therefore, number of liters of fuel required per hour, number of liters of fuel required per hour, number of liters of fuel required per hour is n divided by 3a by b. What is this? This is n b divided by 3b. Right. This is the number of liters of fuel required per hour, people. But on this particular day, number of hours the aeroplane has taken to complete the journey is this. For 1 hour, this is the number of liters required. Then for this number of hours, number of liters of fuel required can be calculated, people. Multiply this by this. Then you can write. Therefore, number of liters of fuel required, number of liters of fuel required on this said day, on this said SAID, on this said day is, on this said day is what, people? That answer is the number of hours it takes, no, that multiplied by this. NB per hour, this number of liters required. Number of hours this particular day the aeroplane takes is that multiplied by this. The time in plus now the top 4b squared minus 2b squared divided by b squared minus 2. Here we get what? Divided by 3 times b squared minus b squared. This is the number of liters of fuel required on the same day, people. Right now?